Alright, 7.3, number 36. We've got find the volume of the solid generated by a revolving triangular region bounded by the lines y equals 2x. Y equals 0 and x equals 1. Alright, so there's x equals 1. So here's our triangular region, and we're going to do two different scenarios. The first one's around x equals 1. So going around x equals 1, you could see that that's going to be a solid. So it's just going to be a disk method. So integral of pi r squared dy. It's y because it's a vertical axis of revolution. So now we just have to figure out what the y is, or what the radius is. And since it's dy, we're going from here to here. So this ordered pair is 1, 2 if you plug 1 into y equals 2x cubed 2. So we're integrating from 0 to 2. So now figuring out the radius. Going out from the y-axis, it's always x. This distance is 1, so this would be 1 minus x. Well, we can't use x, so it would be 1 minus y over 2, because x equals y over 2. So it would be 1 minus y over 2 would be our radius. Part B, going around x equals 2. Alright. So here's x equals 2. And we're going around that. So there's my little r, and then here's my big R. You can see that it's a washer technique. So my big R is this distance, and it does change. So if this is my big R, we know it's this whole minus this part. So kind of like this was 1 minus x, this radius right here would be 2 minus x. But we can't use x, so it would be integral pi, again from 0 to 2. So your big R would be 2 minus x, which is 2 minus y over 2 squared, minus, and our little r is this distance right here. It's always going to be 1. So this distance is always 1, so that's your little r.